Welcome to part 2 of our discussion on stoichiometry. In this lesson, we will define stoichiometry and use the principles of stoichiometry to perform calculations. So what exactly is stoichiometry? Well, technically, it's the area of chemistry that uses mole ratios in a balanced chemical equation to predict or calculate the amount of reactants needed and or the amount of products produced. In reality, what stoichiometry is a way to use chemical reactions, chemical equations, practically in a lab setting. So in a lab, we'll often want to know what quantity of our reactants are required to produce a certain desired amount of product. Stoichiometry allows us to go from a measured quantity like mass or volume of one substance in our reaction to a measured quantity such as volume or mass of a different substance in our chemical reaction. Let's take a look at an example to better illustrate this point. So in this example, they're asking how many grams of nitrogen are needed to react completely with 25 grams of hydrogen in the reaction below. So we're starting with 25 grams of hydrogen, and we need to be able to convert to grams of nitrogen. So before we dive in, let's outline some steps that will help us to approach this problem. So number 1, write a balanced equation. In this case, it was already given to us, but you always need to check to make sure that the equation is balanced before you begin. Secondly, determine the starting point given in the problem on the stoichiometry map. 3, identify the number and type of conversion factors needed, including the mole ratio. And finally, solve using the factor label method and the appropriate conversion factors. So what do I mean by the stoichiometry map? Well, remember we talked about the mole map when we were doing our mole conversions between grams and volume and particles and moles. Well, our stoichiometry map is the same thing, and actually it's just 2 mole maps put together and connected by the mole ratio. So for this particular example, we're starting with grams of hydrogen. So we're starting here with our grams of A, and we're ending at grams of nitrogen. So we're going to end over here at grams of B. Our A is because we're starting with one molecule, and our B because we're ending with a different molecule. So in order to get there, we would need to convert from grams to moles, then from moles of A, or in this case our moles of hydrogen, to our moles of B, or our moles of nitrogen, and then finally to our grams of nitrogen. And just like with our other mole map, each of these arrows represents a conversion factor. So we already know when approaching this problem, it's going to require 3 conversion factors. And we can even go a step farther because we know from our mole map that this conversion factor right here, from grams to moles, is our molar mass. And then this conversion factor, as we learned in our previous lesson, is our mole ratio, the ratio of coefficients in our balanced chemical equation between our nitrogen and our hydrogen. And then finally, this conversion factor here, going from moles to grams, is once again our molar mass. But this time it's going to be our molar mass of our nitrogen. So let's put this all together and apply everything that we've learned to this example. So as per usual, always start with what we were given. And in this case, we are given 25 grams of hydrogen as our starting place. So we need to multiply by a conversion factor because we know we need to get rid of our grams of hydrogen. But what we have are our grams of hydrogen, so that has to go on the bottom, and what we want goes on the top. So this is where we need to refer back to our stoichiometry map. So I'm at grams of A, or grams of hydrogen, so I need to first convert to moles of hydrogen, or moles of A, using my molar mass. So my grams of hydrogen go on the bottom with 1 mole of hydrogen on the top, and in 1 mole of hydrogen there are 2 grams according to the periodic table. So my grams of hydrogen have canceled, so now I need to continue on with another conversion factor. And on my stoichiometry map, I now need to convert from moles of A, or moles of hydrogen, to moles of B, or moles of nitrogen. So I set up my next conversion factor, and what I have, which is my moles of hydrogen, goes on the bottom, and what I want, which is my moles of nitrogen, goes on the top. And now I need to refer back to my balanced chemical equation to get the coefficients to plug into that mole ratio. So in this balanced chemical equation, for every 1 mole of nitrogen, I have 3 moles of hydrogen. So now my moles of hydrogen are going to cancel, but that's not what I want just yet. I need to keep on going. And on my stoichiometry map, I'm at my moles of B, or my moles of nitrogen now. So finally, to get to the answer that I want, I need to do one more conversion to go from my moles of nitrogen to my grams of nitrogen. So what I have goes on the bottom, so my moles of nitrogen go on the bottom, and what I want, my grams of nitrogen, go on the top. And I know that moles to grams is a molar mass ratio, so I use my periodic table, and I have 1 mole of nitrogen equals 28 grams of nitrogen. So finally, my moles of nitrogen have canceled, so I'm left with grams of nitrogen, which is what I want. Now I need to go back and do my calculations. So 25 divided by 2 divided by 3 times 28 gives me 116.7 grams of nitrogen. So what this tells me is that in this reaction, I need 116.7 grams of nitrogen to react completely with 25 grams of hydrogen. When doing stoichiometry, it's really important that you label all of your units as well as the substances that you're working with, so you can stay very organized and minimize the chance of any errors as you're doing your conversion factors and calculations. Now it's your turn to give this example a try. Hit pause on the video, try this example in your notebook, and then when you're ready, hit play to check your work. All right, there you go. How'd you do? You needed to start with what you were given, which was 65 grams of hydrochloric acid, then set up your first ratio, your first conversion factor, and we're here at grams of A, so the first place we need to go is to moles of A. So our very first conversion factor needs to be our molar mass of hydrochloric acid. So then our grams of hydrochloric acid are going to cancel, and we're left with moles. So we're here at moles of A. We need to continue. And using our mole ratio, we need to continue to convert to moles of B, which in this case is going to be our moles of our zinc chloride. So what we have goes on the bottom, our moles of hydrochloric acid, and then our moles of zinc chloride can go on the top because this conversion factor is going to be our mole ratio. So looking back at our equation, for every 1 mole of zinc chloride, we have 2 moles of hydrochloric acid. So that's going to form our mole ratio here. So our moles of hydrochloric acid are going to cancel. So now we're in our moles of B, our moles of zinc chloride. But we have to keep going because they asked us for molecules of zinc chloride. So here we are at our moles of B, and we need to go to our molecules, or our particles of B, our particles of zinc chloride. So what we have, our moles of zinc chloride go on the bottom, and what we want, our molecules of zinc chloride go on the top. And this conversion right here is our Avogadro's number, because we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd. So finally, our moles of zinc chloride have finally canceled, and we're left with molecules of zinc chloride, which is what we want. So now we need to do our math. 65 divided by 36.5 divided by 2 times 6.02 times 10 to the 23rd. And if we input that all correctly into our calculator, our final answer should be 5.36 times 10 to the 23rd molecules of zinc chloride. And that concludes our discussion of stoichiometry. Bring any questions you have with you to class.